Hey guys, how about a little Saturday night restoration project? I've been working on a few AM only Philco radios from the 30s lately, and I thought I'd take a little break and finish this guy off. I'd actually been meaning to do this for a while, I just kept forgetting about it, so here we go. This is an Emerson 602A FM only radio from around 1950. Picked this up, I don't know, 6 months ago or something like that. I'll try to dig up the video I recorded when I got it and post a link in the description. It's a hot chassis. Well, maybe not a hot chassis, but at least it's transformerless. Well, it sure does look like from the schematic that one side of the AC line is going right to the chassis. I hunted around online and I found a copy of the Rider's service info and Beatman. Rider had 3 or 4 pages of info, including alignment instructions and voltage and resistance chart, whereas the Beatman's it's condensed down to 1 page. No alignment instructions, but they do also have the voltage and resistance readings. Never worked on a radio quite like this before. There are 3 iterations of this, the A, the B, and the C. From what I read on a website devoted to this radio, they had some trouble getting it to work very well. And since I have the A revision, which is the first, I'm not sure how well it's going to work, but we shall find out. So here's a tube lineup. It's got a 12BA7, 12BA6, and another 12BA6, a 12S8 GT, that's the ratio detector I believe, 35B5 for the output, and a 35W4 for the rectifier. And it looks like they, no, as I said, they had to add a resistor to drop the filament down, but no, there isn't any. So a little quick math, 35 and 35 is 70. And then we got 4 12-volt tubes, so roughly 48. So yeah, I guess you don't need a dropper that comes out to what, 118, I think. And I'm rounding off because it was a really 12.6 volts, so a little bit more than that. Now I think this will go quick because the capacitors inside are mostly ceramic. I think there might only be 1 or 2 paper caps, and then I believe 5 electrolytics altogether. 3 in a can for the main filter, and there's a little, I think 5 microfarad on the ratio detector, and there's a little cathode bypass on the output tube. It's got the original back, but unfortunately it broke in half. I suppose I can try gluing that back together, maybe use a little filler on whatever gaps may remain and touch it up with a little brown paint. Might not look too bad. But there's also reproduction back available too, but I have not looked into that yet. I did spend a little bit of time already cleaning up the cabinet, so notice note 2. Three more on the bottom. One thing I really like about this radio, other than cool cabinet design, is it's self-contained. The speaker's mounted right in the chassis. Nice, compact, rather easy to work on, I hope. I also like the tuning capacitor on this. They used a similar type that you'd find on an AM radio, but because this is much higher frequency, there's only a couple plates on each capacitor there. I imagine one is for bandpass filter on the antenna, and the other one will be the oscillator. And there we are underneath. So, I was saying not much to it because I use ceramic disc caps. See, there's one paper cap here, and one here, and two more below, so there's more than I thought. Here's one electrolytic, and then there's a can on top. There should be one more somewhere. There's 3 sections in that, and then there's one electrolytic here. There should be another one. Maybe one of these. Oh, I see, this is also an electrolytic. Okay, I thought it was a paper cap. 50 microfarad, 25 volts. I'll use a 47 microfarad, should be close enough. I think this is 5. Schematics are not so hot. Yeah, 5 microfarad, 25 volts. I'll use a 4.7, it's close enough. And the can, I think it's 3 sections at 50 microfarads each. Yeah, and I can't quite make out the voltage. Probably 160 or 150 or something like that. Typical All-American 5 type power supply. So this I think is the clearest schematic. This is from the rider, so there are the 3 50 mics on the power supply filter. Now I have not tried powering it up. So what the heck, I'll throw in a dim bulb in series in case caps are shorted out, and who knows, this thing may actually work a bit on the original parts, but I'll recap it regardless. So I do intend to use this. I think it'll be a nice change of pace to listen to FM radio for a while. I'm glad the original power cord's in decent enough shape to continue using it. It's just a little stiff, but it's not cracked. Because it's got a 3rd wire in it. And that's not for ground. Say it's not a grounded outlet. That is for an antenna. There's just a 3rd conductor that runs to the end and then just isn't connected to anything. And that should serve as a decent enough antenna that I'll get okay reception. Otherwise, there are screw terminals on the back and you could hook up an external antenna. Oh, I also took a needle oiler and put a few drops here and there. And tuning is turning a little bit more easily now. Still a little stiff, but it might be normal, I'm not sure. Alright, so I've got a 60 watt light bulb here. I'm also plugging this into a isolation transformer. This is a hot set. I'll plug that into a variac. And there we go. Everything is on. Turn the variac down a little bit. And let's see what happens. I don't know if this has a dial lamp, so I might not see anything light up right away. 60 watt bulb lit up, dimmed down. That's a good sign. Looks like the tubes are lighting up, which is a good sign, because if one lights up, that means they're all good, or at least have good filament. Listening into the speaker. Hey. There we go. Upper band is completely gone. Looks like we lose everything from like 100 megahertz on, or 102 and on. Stations have changed so much, and sure what's what anymore. Well, WXRT, I'm pretty sure that they haven't changed formats, and they're 93.1. So, okay, the classical station. I think that might be 92.7. $1,000. So this would be XRT, I'm guessing.
Jennings Chevrolet in Glenview has delivered outstanding custom.
And loop should be 97.9, which I'm sure is this. That's good because that means the dial pointer is pretty much on. I won't have to do any tweaking, I hope. I haven't heard that song in a long time. I don't know what station that might be. Something around 90 megahertz.
Have sprung at Menards. All of these were kind of sloppy, insane fun. I'm going to go straight into my number 4, which just came out last year.
Might be WNUR, Northwestern University, 89.3.
As a looper. This is a job that doesn't, because we.
So now the big question is, why does it die? I'm guessing the local oscillator is just crapping out these higher frequencies. I'm just starting to do a little bit of checking and testing. I also clipped out one of the electrolytics so I could get down at the caps below. Here are the new electrolytics I'll be using for these two guys. Luckily I had some axial on hand, meaning the leads come out at the end instead of both at one end. So those will go in nicely. Now I'm checking some resistors. In particular, I always like to check the audio output tube and the cathode resistor here, because quite often I found that they drifted off a value and that affects the output power. So it's supposed to be 180 ohms. Check this out. Measuring about double what it's supposed to be, around 365, not 180. So that is reducing the output power. There's also a 470K in here, and that's not too bad. And I'll keep doing that. Now, a question I often get asked is it okay to test resistors when they're in circuit? Answer, it depends. Depends on what they're connected to. Sometimes you may notice when you're checking the resistor, the value gradually goes up, or down rather. That's typically because there's a capacitor attached to it, and the capacitor is actually charging up from the power coming out of your meter. If you wait long enough, it'll stabilize and you can get a fairly decent reading. But the cases where you can't is if there's something else in parallel with it, like a resistance or an inductor, that's going to affect the value that you're reading. So you should really unsolder one end of the resistor. It's a pain to do, but it's the only really accurate way to test it for sure. Something else I want to check is this big 1K guy in here. That's part of the power supply. So 1130, so it's 13% high. Not horrible, because it is a 20% tolerance, so it's still within spec. So is this 1K resistor. So as I said, I often find that the cathode resistor on the output tube is way off value. I find it kind of curious that it's jumping around a bit, because there's no, I've already clipped the capacitor out, so there's nothing attached to it. So I don't know why that value would be jumping around unless the resistor is really starting to crap out. Curious. Well, I will certainly replace it. I was curious about that resistor, so I clipped it out of the circuit so I can tell for sure there's nothing else attached to it. And see, the value's jumping around even now. And if I touch it, the value's jumping all over again. So I don't know if it's become very temperature sensitive or what the deal is. Let's see, I'll touch it with my soldering iron tip. See what effect that has. Oh yeah, wow. That's crazy. Now what may have happened is there might be some moisture in there. Just by way of comparison, here's what I'm going to replace it with. That should be dead on 180. Yeah, close enough. Soldering iron by that, and this shouldn't drift too much. These metal film resistors are pretty darn stable. Yeah, barely changing at all. So far I've replaced 2 electrolytics and 2 paper caps and that 1 resistor. I'm going to try powering it up, see what kind of changes that may have made, if any. I also noticed that that third wire I was talking about in the power cord that forms the antenna wasn't actually attached to the screw terminal in the back. It was hanging loose. So I'm surprised I was able to receive what I was without the antenna being hooked up. Alright, so let's all plug it back in. I checked most of the other resistors, and they were actually all within spec. Can't say I really detect any huge difference. And we still lose reception above 102. I wish I'd cranked it up all the way before I changed that resistor, because I'm not sure what difference might have happened with that resistor, because it seems like I have plenty of volume now. Alright, so I still have 2 paper caps to go. And then I can start checking around the tuner part and maybe get a scope on the oscillator, see if it's really crapping out. Also, I check the tubes too. It's entirely possible that the 12BA7's just gone bad. That's the first tube there. I believe it's multifunction, like RF amp, oscillator, and mixer. I finished checking all the resistors, and the only other one I found that was off a little bit was this 39 ohm. I think it's a 1 watt resistor. Now, unfortunately, I don't have any on hand, so what I ended up doing is I put a 180 ohm resistor in parallel with it to knock the value down. So it's pretty close to 39 now. I also clipped out a capacitor that had been up in here, which goes directly across the AC line. So it's not critical to the operation of the set. It's there to filter noise out of the AC line. You should really use an AC rated safety cap for that. I don't have one on hand that's 0.05, so I'm just going to leave it out for now. And it leaves one paper cap, which is down here and a real pain to get at. And that is on the volume control. And I'm not real concerned about it, because that part of it seems to be working okay. I'll get to it eventually, but I'm more interested in knowing why I can't tune this portion of the dial. So next up I want to check the tubes. And when I pulled them all out, I was surprised to see that they are all Emerson branded tubes, so it's very likely that these are the originals. And assuming this radio saw any use, probably a bit worn out by now. Unfortunately, I looked through my entire tube stash and I don't have any 12BA7s. I guess that wasn't a very commonly used tube. Plenty of 12BA6s and a 35W4, 35B5, so I can replace most of the tubes, but not the one that I really care about. So I'll test the one I've got, and then I'll I guess I have to pick one up somewhere. I also couldn't find any 12S8s, but that I'm not too concerned about, because obviously the ratio detector is working because we're hearing sound. Not surprisingly, those tubes do test pretty weak. I just checked the 12BA6s, and they're just on the edge of green, so just barely into the good. So I'd like to replace them, so I dug out some 12BA6s and I'm testing them because they're used. And I thought I found a good one. The quality checks quite good. And then I did a gas test, which I often neglect to do because I had just never found a gassy tube, so I kind of often skip that step. But just, I don't know why, but I could push that button and check it out. That is a gassy tube. So some air must have leaked in there and it's getting ionized when you do the gas test. And of course, it's well under the replace bad range on the gas part of the meter, so that tube goes in the garbage. I had to switch to a different tube tester to test the 12BA7 because I don't have a card for it, my Cardmatic tester. So pulled out the 600A, and not too surprisingly, when I check the amplifier section of this tube, we're in the replace section. And now I'll check the oscillator portion of the tube. 2913-7. 2913-7. 031 P4. We're in the question mark zone. So, kind of what I suspected. This tube is barely, well, it's in the replace section, so that could very well account for the problem. Not 100% sure, but it seems like a good idea to replace it anyways. I hopped onto eBay and I got loads of them for sale, so I guess this project will not be completed tonight. Maybe in a few days I'll find a replacement tube. I also think I'll hunt around. I maybe can pull one out of another set. I'm not sure. Like, I do have a GE AM/FM radio from around the same time period that might have one in it. I finally managed to dig up a couple 12BA7s, so I'll try popping one in and let's see if it fixes the problem. Nuts. Same problem. I think I might be onto something. I was guessing as to what stations I was hearing as I was tuning around, but I just noticed that when I was around here, I caught the station ID and they said it was 100.3. So maybe all along the whole band has been shifted over or compressed into this range. So I think I got to get another FM radio or something and figure out, or fire up an RF generator and figure out where am I at on this dial. Maybe all I need to do is adjust these trimmers here and everything is just fine.
What you want is simple. Great rates and someone.
Alright, so this is the oscillator screw, and I noticed it was actually fairly loose, so I tightened it down a bit. And actually what I did is I put the pointer all the way to the end of the dial, so I know there's a station on 107.9, or at least I think there is. And I joisted the oscillator until I got a station there. And now I got stations across the band. I still need to actually pinpoint which stations are which, and see that the dial's actually lined up right. Well, we're just about 4:30, so I should get some station IDs coming through soon. So I've got stations going from one of the dial to the other.
John Fogerty, it's 93 XRT.
Alright, I was pretty sure that was XRT, so 93, we're about alright there.
Step to B.
Jane Schlesinger, News Radio 780 and 105.9 FM.
WBBM News.
And that's 105.9, so that's off a little bit. 105.9 should be about over here. Well, I'm getting close, so now I'm convinced that is the problem. So all along, I'll be screwing around with tubes and this and that. It was just that these were way off, so enough screwing around. Gotta get out the test equipment and do this properly, and align these and get that local oscillator set up right so the dial's correct. Unfortunately, I don't currently have a good sleep generator suitable for aligning FM radio, so I can't do the visual type of alignment. Instead, I'll do the top portion here, which is using an AM signal generator and VTVM. So here's my good old RCA volt ohmist for the VTVM, and my leader 17A for the RF generator. They give you a little tick mark there for 10.7. I verified that with the frequency counter that it is indeed 10.7, unmodulated. You feed it in via a 0.005 microfarad cap. I'm using 0.0047, close enough. That goes to pin 1 of V3, which is the tube right before the ratio detector. So in other words, we're going to first adjust the coil towards the last stage and then work our way back. And the meter is attached down in there, which they show in the schematic as point B. So it's part of that ratio detector output there. Now, first step is to adjust this A2 coil for maximum output. That's that big coil you see at the end there. And they're talking about the bottom end. There's a slug at either end on that coil. So we are adjusting A2 first for maximum output. Simple enough. Get your alignment tool, plastic tube, metal slot on the end, so your body doesn't affect the reading. You want to use the lowest RF level so you get a decent meter deflection. Let's see, that was off a fair amount. Lower my output level. Drop this down to a lower range. Drop the RF a bit more. The reason you want to use the smallest input level, we get decent deflection, is that so you're not overloading the amplifier. Alright, that's good right there. I saw this, you'd see that that was off a bit, so That should help improve the performance a bit. Alright, next stage. Looks like we keep most of the settings the same, which is handy. I have to move my probe to point A. So we've got to pick up a couple 100K resistors and connect them between 2 points and hook my meter up to that. And then we adjust the ratio detector. Now that's normally where ideally you could do it visually and you could see a nice S-curve. This is kind of an odd way of doing it with 2 resistors. The way I've seen in the past with a VTVM like this is with 0 input, you adjust the 0, adjust so that it's on dead center there, and then you vary your RF generator a little bit and you see that the needle deflects plus and minus equally. But I'll go with their technique. That's what they recommend, so I'll have to dig out some parts and alter my setup a little bit. Here are the 2 resistors I just tacked in temporarily. The junction of the 2 goes to ground on the VTVM, and the positive goes to pin 3 on 12S8 tube. Now don't get caught up too much in these directions because these are specific to this particular radio. They're going to be different for every radio, so you've got to get these instructions for your particular radio. Alright, now we adjust for minimum output, not maximum. And that is the coil on top, so I'm going to flip this down. Had a couple cardboard struts lying around from a recent cathode ray tube delivery I got, and they turned out to be pretty handy to jack up radio chassis while you work on them. Alright, so they want a minimum. Now what I'm guessing they mean by minimum is the most negative. Right now I have this on minus DC volts. So when they say minimum, do they mean a large negative value or do they mean the least negative value? In other words, the smallest meter deflection when it's on negative DC volts. I'm not sure. I think they mean you want the most DC value because that's the only peak I'm getting as I rotate this. If I just keep turning and turning, it just bottoms out around there on the meter. Likewise, if I go the other way past that point. Oh, maybe not. It seems to just be pegging the meter now. So, I've been confused by that before when they say minimum. But I can see from the discoloration on this slug about where it was originally, and it's got to be in the ballpark of where it's supposed to be. So I think they mean maximum negative deflection. That's what the minimum would be. So that's going to be right about there. And then it gets a little more conventional for the last part. Going to relocate where the RF comes in, move the DC probe a bit, and then we're just going to start tweaking coils for maximum for the IF stages. Now I can finally take care of that pesky problem of the needle napping on the station properly. So, according to the alignment instructions, you hook your meter up to a certain point, put the dial on 108, and feed an RF generator into the antenna terminals set to 108. So, I use my frequency counter to double check it, and I got this set on 108, and you can hear it coming through the radio now because I turn the internal modulation onto my RF generator. And then you supposed to tweak the oscillator, which I've already done a bit, so I can hear it while I'm watching the meter for maximum output. Now it's going to be a little tricky because if you watch this meter and you see got a reading about there, and it goes louder. That's because I'm picking up a radio station. Because we've got a station here that's close to 108, probably 107.9. That's why I put the internal modulation on to make sure I was peaking to my actual RF generator and not some local radio station. So right about there. And you can kind of do this by ear, but watch the meter as well. So now hopefully that will be in line. Now the other one is for the antenna trimmer. It seems to me you could probably just leave it on 108 and trim it, but they said I got a 106 instead for whatever reason, so I'm not going to set the frequency counter again. I'll just knock this down a little bit and figure 106 is probably about there. Let's see if I got that right. 200 radio. Oh, it's close. I know we have 105.9, so it's bleeding in too, so I'm actually going to go a bit off. Pick at that spot right about there. Just the RF generator again. Right there. And now I'm going to tweak the antenna trimmer for maximum output. Again, you can look at the meter, or you can just kind of do it by ear. Right about there. Alright, that should be it. Alright, after all that, how does it sound?
Call 1-800-RED-CROSS or visit redcrossblood.org today. Roll up a sleeve and help save a life.
Hey, what's up, y'all? It's Chris. Check this out. This summer, Neo and Cher Lloyd are coming together to write a song inspired by you.
All begins at 10 a.m. For more information, visit phoenix.edu/policeweek.
It sounds pretty good.
Hey, Cliffs, never tell a zombie he looks like death warmed over.
It's here, only at Best Buy. Check out the Samsung.
Now keep in mind it's just mono reception out of a little speaker, so it's not going to sound as good as a stereo receiver.
'97 at 9 won't keep that lady you work with from telling long, boring stories.
No me dejes así, no me dejes llorar.
Now let's take a look at this back. I'm thinking what I can do is get the pieces lined up well, and then use something like toothpicks or maybe some hardwood, basswood splints, and glue them on the back to add some more support to it. And once I get that glued back together, it's set up, I can flip it over and then touch up the other side as needed to make it look a little more respectable. I actually ended up using popsicle sticks for the back. I believe these are white birch and stronger than the basswood I was contemplating using. So I took a utility knife, cut them down to length to make the strips smaller, and then cut them to length. A little bit of carpenter's glue on the back, put a weight on top of it, and set up. I then took a little bit of walnut wood filler, filled in the voids a little bit. Doesn't look too bad as is, I think, but I suppose I could try mixing up a little bit of paint. I've got some dark brown artist acrylic. Maybe if I mix in a little bit white to lighten it up a little bit, it would be a decent color match. I just finished the final touches on the electronics of this radio. I figured out how to remove this so I could get down into the control here, clean that with some deoxit, and I replaced that long capacitor I was having trouble getting at. And I also installed a fuse. Found a nice open area. There was already an empty hole drilled into the chassis, so I mounted a clip-in fuse holder and popped in, I think it's a 7/8 amp slow blow fuse. Just that's what I had on hand. It seems like a reasonable size fuse to use. And for now, because I still don't have a 39 ohm 2-watt resistor on hand, we're just going to go with that kind of kludge repair over there. Alright, that's that, and I'm going to put it all back together now. And finally, here it is all back together. I touched up the brake on the back with a little bit of dark brown paint. Not a perfect match, but at a distance, it's not too noticeable. Still has some scuffs here and there in the cabinet. Maybe those could be buffed out. I'm not sure. Doesn't bother me that much. I'm just going to leave it the way it is. And the radio's working fine.
I'm gonna put you in your place.
Hope you enjoyed this restoration project, which ended up taking a lot longer than I expected, but I suppose that's what makes this hobby fun.
Time it seems like ain't nothing left no more. I find myself having to reach out and grab hold of something. Yeah, I just catch myself wondering, waiting, worrying about something silly.